I'm basically from Kolkata. I did my studies from Calcutta University and Jadavpur University, and I started my career long back. I was fortunate enough to be a part of a very premium institute in Kolkata, Scottish Church College. I had been there for many years, and then I moved into Delhi in 2008. It's been again 15 years now. So I'm associated with many management school, the B schools in Delhi and NCR, and currently associated with NDIM, New Delhi Institute of Management, which has been declared as the best management institute of India for industry linkages for 3 years in a row by the AICTE and CII. And it also has been elevated and declared as the first and only mentor institute in India in the management category by the AICTE and CII. I would like to thank the entire organizing team, AK Dasgupta Institute, and of course, Vishwa Bharati for conducting this 14 days workshop on qualitative research and giving me an opportunity to deliver a session. So again, a warm welcome to all the participants from academia, research scholars from various universities and colleges across the Pan-India for joining my session today. My session topic is sampling techniques and sample size determination. So as he mentioned that it is a very critical part of the research work, I'll try to deliver as in a simple manner and would request the participants to take part in the discussion. Wherever they have doubts or any points to discuss, they can, they can interrupt the session. They can, just raise their hand or write in the chat box. I regret for my this husky voice. I am actually suffering from a bad throat because of the harsh cold weather and the severe pollution in Delhi. So if there are any instances or any moment where I'm difficult to understand, I would request the participants kindly let me know. So with this note, I'll continue the topic sampling technique. So what I'll discuss today, I'll talk about the various sampling techniques which is available to the researchers whenever a researcher is conducting a quantitative or a qualitative research or a mixed methodology studies. And a very critical question again, which every researcher is looking for an answer: what should be the appropriate or right size of the sample for a research work? Now, I would begin this. Before I begin this session, I would request my participants if they can share their experiences on research, what kind of research they have conducted in the recent past, qualitative, quantitative, or mixed methodology, and what sampling techniques they have used or deployed in their research study. So if anybody from the audiences, if you want to speak.
Yeah, recently I have conducted a study on stakeholders' perspective of social work education in the state of Telangana. Okay, we have gone for purposive sampling.
All right.
And also for selecting the colleges, we have gone for multi-stage sampling.
Okay.
So
right.
yeah.
Mm-hmm. Okay. So may I know your name, please? It's showing Pallavi on the screen.
No, I'm Dr. T. Sridhar. It's my daughter's login. Yeah.
Okay. All right. So anyone else would like to speak their research experiences, what challenges they have faced while selecting the sampling technique, so that we all can learn from the experiences. Otherwise, I'll start from the very scratch because I can understand there can be some participants who are very new to the research, maybe. Anybody else would like to speak? Okay, I'll try it. Okay, so I would begin the session with an interesting quote, which is, of course, by somebody unknown, that sampling is the artist palette. where a select few strokes craft masterpiece of insight from the canvas of data. So this quote says that sampling is an artist's palette. It involves a deliberate choice of elements from the vast canvas of data. Just as an artist selects specific strokes to shape a masterpiece, sampling meticulously picks representative data points to create insightful conclusions. It also enables us to showcase the richness of the data landscape while extracting the core elements necessary for comprehension and interpretation. So just like an artist, it's that handpicked few data points from the entire population, and that sample should be representative enough, representative in such a manner that a meaningful interpretation about the whole can be made. So my session for today, uh, I'll just discuss the plan. So first I'll talk about the very fundamental concept of sensors versus sampling, which we call complete enumeration and selective enumeration. Then I'll discuss various sampling techniques used for quantitative research and qualitative research. And moreover, I'll end the session by discussing how sample size can be determined for both quantitative and qualitative sampling. So if I talk about sensors, I'm sure all of us know, just a reiteration, sensors which we call complete enumeration, it is a study where each and every member of the population is being investigated. It's a detailed study where information we extract for each and every member. Now, this study of sensors, it has some advantages. At the same time, it has some disadvantages. So pros and cons, if you look at, the advantages will be, since we are collecting information from each and every member, it is a very detailed study and therefore a higher standard of accuracy can be achieved. But the cons, it is very time consuming. It deals with a lot of cost. It's a costly affair, and a lot of energy also it's required. And there are certain instances where complete enumeration is quite impossible, and that's why as a researcher we look for an alternative, and the alternative is sampling, or which we call partial enumeration. So here the concept is again very simple. By sampling, we mean that a subset of the population. The population which we study, the population of interest, from that when we pick a small part is called a sample. And information from the sample. Now, why do we do sample? The sampling is basically used to draw, the inferences or conclusion about the entire population we study. So from the entire population of interest, when we pick a small sample and we study it thoroughly, the information from these sample units, we use it to estimate, to gauge the likely characteristics of the entire population. All right. So now the question here, though the concept of sampling is very easy, the question which is very important to answer, that what technique shall we deploy, shall we use to pick this few observations from the aggregate or totality or the population so that the sample can adequately represent the population. All right. So now these are the, again, I'm not discussing the pros and cons. They are every coin has two sides. Both the techniques has its own merits and demerits. The demerits of sampling is that it might include the individual or the researcher's biases. And also there can be possibility of sampling error. I'll come to this. The sampling error is that the information or the sampling, the estimate and the census information. So sampling information which we get from our own sample and the census, the differences or the divergence between these two is called the sampling error, which is, you know, totally we cannot avoid it. It is unavoidable. There will be sampling error, but it is entirely the researcher's skills. If the researcher has skills and expertise, he can minimize it by using right tools, right set of sampling tools. So that we will discuss in the later course of time. Now, as far as the types of sampling is being considered, the sampling can be, we can have two broader types of sampling techniques. They are probability sampling, which is also known as random sampling. And another type of sampling is non-probability sampling, which is also commonly known as non-random sampling. As the name suggests, in probability sampling, the samples selected according to some chances. So selection is entirely based on chance factor. It is not based on any pre-decided or predefined criteria. So we call it, the selection is not based on choice, rather based on chance. And in probability sampling, every item in the population has some known chances of being included in the sample. So what are the, apparently, so it's simple, like in the probability sampling, which is used in the quantitative research, is widely used. The selection will not be on the basis of some criteria or choice. The selection would be based on the chance. So all the members will have equal opportunity to be the part of the sample. And under these, there are four techniques which we will be discussing. We will be learning in the today's lecture. That is a simple random sampling, systematic, stratified, and cluster sampling. So now in the probability sampling, though the selection is entirely based on chance, and today my discussion, the delivery will be on the conceptual part. But if you ask me in the real research work, how do I do it? We do not do it manually because first of all, to perform this probability sampling, we need to have the census data. Otherwise, we can't do this probability sampling. So I use various, computer software. I use Excel, and I'm also have expertise on our studio. So we have some coding, some, functions. We use random functions. We take the help of random number generator. So it is totally free from the personal biases. Okay. But as I mentioned earlier, it can only be used, and we can select or recruit the sample by using this technique only if we have the detailed information about the entire population, which is a challenging, and that's why we switch to the qualitative research techniques, that is the non-probability sampling. Okay. So before I'll discuss about the probability, I thought to start with the non-probability because the theme of this workshop is qualitative research. So I thought let's first talk about the non-probability sampling techniques, which are basically deployed or used for the qualitative researchers. So as the name again suggests, it is just opposite to the probability sampling, and it does not rely on randomization. Rather, the entire process is based on the researcher's own decision or own discretion Researcher exercises the choices on the basis of some criteria, some predefined parameters. The samples are being taken, extracted from the population. Now, what are the techniques which are available under this non-probability sampling? Let's see their names. They are convenience sampling, purposive sampling, we have snowball, and also theoretical sampling. Now, choosing the right sampling technique significantly impacts the accuracy and reliability of the research results. So, it's very crucial to consider the potential impact on the bias, then sample diversity and generalizability, which means whether my sampling, the findings from my own sample can be generalized for the other studies or not. So when we are choosing right sampling techniques for our own qualitative research, we should keep this points in our mind, because qualitative research, it involves collecting non-numerical data. We don't collect numerical facts. Mostly we use interview techniques like focus interview, observations, or we can go for exploratory study, some written documents to gain insights into human experiences, attitudes, and behaviors. So while qualitative research can provide rich information and rich findings, but the accuracy and generalizability of findings from the qualitative research largely depends on the quality of the sampling process. So, sampling is a very critical component of qualitative research, as it involves selecting a group of participants who can provide valuable insights into the research questions. And then we can also, first I'll discuss all the four techniques one by one, and in the end we can compare and contrast these techniques so that we can have more clarity and we get guidance on choosing the most appropriate method for a particular study we undertake. So moving forward, the first one is purposive sampling. Purposive sampling, as you said, already one of my audience has already used it. So, as the name again, the purposive, it is a sampling tool for the researcher where a researcher is seeking to select participants who can provide valuable insights into their research questions. So, that means the participants, when we are selecting, we are not choosing them randomly. We are choosing them purposefully. But that's why it is also known as judgment sampling. So we exercise our judgment. We know who are the participants who will deem fit to our study, and only those participants who are deemed fitted will be picked up for our study. So this method is advantageous when studying groups with technical characteristics or experiences where a random selection of participants may yield different results. So the random selections may not give us the results which we want, and that's why purposefully we choose those who have the technical knowledge or experiences on the topic of the study we have taken. So purposive sampling, which has different names, as I have already talked about, we can call it judgmental sampling, we can call it selective sampling, we can also call it a subjective sampling. So it's one of the very important form of non-probability sampling in which the researchers rely on their own judgment while choosing members of the population to participate in their surveys. So I would like to pour an example. Suppose a researcher wants to study on, you know, women entrepreneurship among in developing countries. So women entrepreneurship among women in developing countries. So this particular study could utilize purposive sampling. Now, why I'm saying so? Because the selection criteria might include women involved in various types of businesses, different levels of educational background, who have access to financial resources, and they're from different cultural background. So intentionally selecting participants, representing diverse, entrepreneurial ventures and backgrounds, researchers can understand, you know, the challenges, the success, and the support that they need, that is specific to, women entrepreneur in this area. So purposive sampling in this scenario allows researchers to gather insights by deliberately selecting participants who represent, different aspects or variations with the broader subject of the study, and offering a deeper understanding of the targeted issues. So this kind of, purposive sampling, it requires researchers to have prior knowledge about the purpose of their study. So, if the researchers are very clear about what study they are conducting, who are the target audience, they can choose an approach to the eligible participants. Now, another one I have taken from one topic from the social sciences. If somebody wants to conduct a study on domestic violence survivors support services. Now, investigating the effectiveness of these support services for survivors of domestic violence. This also may involve purposive sampling. Here, what researcher can do? Researcher can, identify some, some support, services where they can contact the survivors of domestic violence, and by, contacting them, the, you know, information can be collected based on their experiences, what kind of abuse they have, abusive situation they had faced, duration of their stay in the shelters, and what kind of legal or counseling services had been given to them, and also, studying different demographic factors such as, age, because this women will be from different age groups, from different socioeconomic status, their ethnicity will be different. So in this kind of, study, the purposive sampling allows for an in-depth exploration of survivors need and effectiveness of interventions. So moving forward to the next part. Now, selection, it's already been discussed. What are the steps we follow in purposive sampling? That is quite simple. First one, the researcher, has to select participants who are relevant to the research questions. So once you design, you have the set of research questions, these are the target audiences from where the information needs to be collected. So we have to identify it, and then we collect data. We have to make our sample as diversified as possible. So if we collect data from diverse participants with unique perspectives and experiences related to the research questions, okay? So these are the steps we follow. And of course, like I mentioned, every tool and technique, it has own merits and own limitations. So this technique does not involve much expenses, does not require much time as compared to the other techniques, which I'll discuss later on, like stratified sampling and all. So like in comparison to the other tools which we use, The purposive sampling may require less time and the less expenses. But there are, limitations also. The limitation is it is highly subjective. So researchers should also be aware of potential bias when using purposive sampling. So the researcher's judgment may influence the selection of participants. So while selecting participants, our individual biases, our individual judgment, might be, it might make the sample, somehow biased. So a biased sample does not accurately represent the broader population. And the another limitation which I have pointed out, that the generalization is not appropriate. The my findings, my own research findings, the outcomes, it may not be possible to generalize it for the other, other similar studies or the similar groups, because purposive sampling may not be representative of the more general populations. So it limits the generalizability of the findings. So to guarantee the accuracy and dependability of data obtained through purposive sampling, researcher must provide a clear and transparent justification of their selection criteria. So when you are designing your research methodology and mentioning the technique as purposive, you know, sampling technique, you should be very clear and transparent of the selection of your sample. So if there is a transparency, if there is a clarity and the justification, it will help the other researchers to understand it, and also, it may be helpful to, generalize it or create a replica of, similar kind of researches. So this entails outlining the specific characteristics or experiences required for participants to be included in the study, and explaining the rationale behind this criteria. So this level of transparency, it not only help, readers like, researchers and readers like, we all us, it also helps to evaluate the validity of the findings, and it enhances the replicability of the research. So another one which is very similar and often, it's taken as the interchangeably, people, might mistake and take it interchangeable, but there are maybe some similarity between them, but these two sampling techniques are totally different. So I have already discussed the purposive sampling. Now I'm moving forward to the next one, which is again very important, which is convenience sampling. And I have few research papers where the researchers have used it. So if I get time, I'll show you those research paper. I have the links. So the convenience sampling, it is again, as the name suggests, convenience sampling is the easiest one adopted by the researchers, where they collect, data from a conveniently available pool of respondents, right? So the name says that when the time and the resources are limited, researcher might opt for convenience sampling as a quick and very cost-effective way to recruit participants. So in this non-probability sampling technique, participants are selected based on their accessibility, their availability. If they are easily available, those participants who are readily available and they're willing to participate, they will be picked up rather than looking at the suitability of the research questions. So how to use it if that question comes in our mind? So convenience sampling is the easiest sampling one. And we don't need much expertise or skills, or we don't have to use very complex procedures to pull it off. A simple guide on how to use this in our systematic investigation, it's quite simple. Let's take an example to understand this. Suppose I want to study the buying behavior of the women towards smartphone. Um, so what I did, suppose as a researcher, I decided to go to the popular malls, the malls which are very nearby and not far distant. And what I did, I identified few women um, of different age, of different occupation. Some, are mothers, some are working professionals, some are homemakers, and I recorded their responses and collect the necessary data. So by doing this, can anybody point out anything we missed out? The convenience sampling apparently is very simple. So the instead of going to the malls or to the location which is beyond my accessibility, I only went to the mall which is very close to my home and my proximity. So anybody from the audience, any shortcomings of this convenience sampling?
Yeah, you would be concentrating only on one location and you will be concentrating on few respondents. This may give to a biased outcome because your
Right.
study is not diverse.
Exactly. Exactly.
Yes.
Thank you. Thank you for the insight. That's why what happened. So, in this particular study, when I went to specific malls, as Sir mentioned, so I left out every woman who wasn't there at the mall at the time of the data collection process. So see the smartphones, if we look around, almost every individual, every person is using smartphones. But if you talk about the mall, suppose I went to the mall, which is a Select City Mall, very close by, it's in the South Delhi, which is normally the footfall, if we look at the upper middle class or maybe the higher income groups that mainly comes for shopping or maybe window shopping. So the women who are in a lower middle class income, so we are not considering them in our study. So that is something, diversification is something which is not part of my study. All right. But, despite being this disadvantage or limitation, this convenience sampling is very popular. Let me give you one example. So during the COVID-19 pandemic, amid the pandemic situation, we all are into an education field. So the education system, it underwent a significant shift, transitioning from traditional offline learning classes to predominant reliance. We become so dependent on the online education. So if my study is to understand the experiences of the, say, management students during the pandemic, so when this transition happened, what kind of experiences do they think that online teaching or learning, it was effective as offline learning, if this is my study topic is. Now, as a researcher, I would prefer a recruit convenience sampling. Why so? Because all the students may not be available to me, and students who are easily accessible and students who are willing to share their experiences quickly, I can identify them, include them in my sample, and I can quickly complete my research study. So this is the ease, and because of this ease and convenience it has, this often gets a preference over the purposive sampling. Now let's move to another very important sampling, snowball. And snowball is kind of a chain referral sampling, and in which the samples have traits that are rare to find. And this is a sampling technique in which existing subjects provide reference to recruit samples required for research study. Now, what is this study all about? So basically, as a researcher, I would prefer to use NOVA sampling when recruitment of participants is little difficult. So the technique, involves identifying few initial participants who meet the eligibility criteria. So if I can identify few respondents who are meeting my research, the target audience criteria, okay. So I'll approach to them and I might ask them to refer others who also fit into the requirement. And this way, the sample size it grows as referrals are added, and it creates like a chain like structure. So, snowball sampling it enables researchers to reach out to individuals who are otherwise hard to locate. For example, in the social sciences, suppose if I want to study or examine the experiences of the undocumented immigrant. So, I mean, at the time of partition also, people had to move out, like from the East Bengal, people moved out to Bangladesh, some moved out in Delhi. So, if I can identify few initial participants who had faced this, immigration, and then from them we can ask for further references. So this way the snowball sampling can be used to identify and recruit participants through referrals, and we'll have a kind of a chain line structure. So snowball sampling, it has the advantages, of course. So snowball sampling, we get in-depth and detailed data from the participants with the common characteristics or experiences. And since the referrals are made within a network of individuals who have similarities, who have similar experiences, researchers can get deep insights into a specific group's attitudes, their behaviors, and their perspectives. So these are some of the articles, if you allow. Um, just let me check. So this is one topic, that how social media, so using social media and snowball sampling as an alternative recruitment strategy for research. I'd request the participants, if they quickly they read the abstract.
Uh, Sorry, ma'am, we can't able to see, ma'am.
Okay, okay. All right. Maybe because my screen is okay. No issues. Um, this is basically a topic undertaken during the COVID-19 pandemic. So, as I mentioned, the COVID-19 pandemic demanded rapid change in healthcare education. I'll share the links, sir. No issues. The COVID-19 pandemic, it demanded rapid change in the healthcare education, so moving many students to online learning. So it is important to examine how this shift affected both student perception of learning and achievement of learning outcomes. So in this snowball, the researchers, they deployed snowball sampling strategy to reach and recruit nursing students who are otherwise, in fact, difficult, hard to identify. So the nursing students who had shifted to online learning during the pandemic to participate in a research study survey. So, and this paper outlines the process of snowball sampling using social media, explored the relationship between social media post and the survey completion, and also discusses the challenges and the benefits. Just a minute. Hope my screen is visible now. It's, is it okay?
Yes, ma'am. Yes, ma'am.
Okay, and then the last one, which is remaining, is the theoretical sampling. Theoretical sampling is a kind of a sophisticated and strategic technique. So it is used when researchers conduct grounded theory. I'll not touch it because it's an important part of qualitative research, and I do not have much expertise on it. I'm more into quantitative research, and I'm an economics faculty. I teach statistical tools and techniques in my institute. So this is just I would like to touch and discuss. And if anybody has experience on it, they can also share it. So this is basically a kind of a strategic technique that can help researchers to develop more in depth and develop theories from the data. So instead of selecting participants based on convenience, which we did in the convenience sampling, or based on the accessibility, researchers will use theoretical sampling, uh, where the participants will be on the based on the potential to contribute to the emerging themes and the concepts in the data. So this approach allows researchers to refine their research questions and the theory based on the data they collect rather than forcing their data to fit a preconceived idea. What does it mean? It means that when a researcher wants to develop some theories, there is some wants to develop some initial theory or some conceptual framework. Say for example, in a study examining cancer survivors experiences. Okay, so in that case we can use theoretical sampling, because theoretical sampling will help the researcher to identify and recruit participants who can provide new insights into the coping strategies of survivors, and therefore it helps the researchers to develop or formulate some new theories. So if you talk about strengths and weaknesses, so it has significant advantages. It allows researchers to refine their research questions and the theory based emerging data. So which means that research can be highly targeted and focused, leading to a deeper understanding of the phenomena which is being studied. Um, Now, again, this is the challenge in every non-probability sampling. Every non-probability sampling somehow might have the biases. So, how we can mitigate the potential uh, for bias? Now, what the researcher can do to reduce the bias, one can use a diverse team of researchers. It's a pool of researchers. So instead of somebody just one individual's perspective in analyzing the data and in choosing participants. So if we have a pool of research teams and experts, so having multiple perspectives and backgrounds, it can help prevent researchers from unconsciously sometimes we become biased. So that biasness we can reduce, we can mitigate when we have a pool of team with a different perspective, and everybody will exercise their own perspective in selecting participants who fit the research topic questions. Now, in conclusion, the question again, where the bottom line is the what are the factors we should consider when choosing a sampling technique? So choosing a proper sampling technique is one of the most critical decisions a researcher makes when conducting a study, and the preferred choice significantly impact the accuracy level of the research and of course the reliability of the research. What will be the research outcomes? It significantly depends on what techniques or tools we have used in the sampling methods. And also the choice of sampling techniques, it impacts on the generalizability of the research. We have already talked about it. So it's crucial to consider, I mentioned that is the buyer sample diversity. and the generalizability of choosing a sampling technique. So, for example, for instance, if purposive sampling is it's being taken because provides more targeted and specific sample, which helps to answer research questions related to that particular population or phenomena. But it has limitation. This approach might introduce biases by limiting the diversity of the sample. So conversely, if we go with the convenient sampling, now convenient sampling, it offers more diverse sampling regarding demographics. It may be the backgrounds we choose, but also at the same time, because we choose only those, because in the convenient sampling, we chose those who are willing to participate. So that also might introduce the biasness. Uh, Snowball sampling may help study hard to reach population, but it can also limit the sample's diversity as participants are selected based on their connections to existing participants. And lastly, theoretical sampling, it might be an opportunity to refine the research questions and the theory based on emerging data, but it is again a time consuming and resource intensive. So my final thought is that we need to weigh the pros and cons of each of these sampling techniques. And accordingly, researchers is entirely on the researcher's discretion that which particular, tools and techniques will be the most appropriate for their own study. So researchers can make informed decisions that lead to more reliable and accurate results. So, lastly, I conclude that a careful selection of the sampling technique is a very integral part, it is crucial part for the success of the qualitative research study. And a thorough understanding of the all the available all the available options will make all the difference in achieving high quality research outcomes. So our research outcomes will be achievable only when we have thorough understanding of all the techniques which are available to us. And selecting, we have to select the sample very meticulously, very minutely, so that that gives us the success to the qualitative research study we undertake. So any question till now?
Hello, ma'am.
Yes, please.
Ma'am, in case of purposive sampling, the researcher has to follow some judgment like age, gender, whom to select and whom not to select, and should have a clear justification behind the
Right,
selection.
right. So we are taking information only from those who have expertise over that area. So suppose
Yes, ma'am.
if I'm so it's only the pool of experts who can give better insights to my own research rather than approaching to a layman.
Yes, ma'am. But sometimes it happens like we implement some inclusion and exclusion criteria that is predetermined, and then we randomly select some samples. So can we see this can be purposive sampling, or it will be simply random sampling?
Inclusion and exclusion, ma'am, can you just elaborate how you are excluding some? Because in probability sampling, first of all, we need the information about the entire population of interest which we want to study, and then we don't exclude anybody from the study. I mean, first we have the total, and then we have, I mean, I'll explain the simple random sampling when we talk about. So randomly, I mean, even the random selection, if you ask, so there can be some confusion might arise how to choose that. That maybe a lottery can be a right choice in that. Otherwise, we have the functions, rand functions. So we use rand functions to completely eliminate biases. So entirely, this is the computer generated the random sample. But in the purposive sampling, what we do, we select a small part from the entire purposefully. So we have clear justification of why I have selected X, Y, or Z, why have I have given them preferences over the others.
Okay, okay. So in some problems when we select any specific gender or specific age group or any specific type of people for our research purpose,
Hmm.
that can be purposive sampling as we are purposefully selecting those.
Yes, because like when we are launching, suppose a product experiences, so the consumers who have bought the product, they only can share the experiences. So random sampling, I mean, see the probability sampling. Apparently, though it sounds simple. Now, getting that entire database is a challenge. Like in the domestic, when I talked about the domestic abusive survivors, so like the data of all the survivors of the domestic violence or domestic abuse, so that entire database I might not get, but I might approach to some of the NGOs, and from them I can get the data. So it's the census is not available, right? So random sampling technique can only be exercised when we have the complete database, the information about the each and every member of the population which falls in our study.
Yes.
Because of this challenge, we switched to the non-probability sampling. And in non-probability sampling, so the first question while choosing the sampling techniques, so that not only your research questions and research objective, we have to ask this question: do we have the entire census data available with us? If yes, we might think of probability sampling. But if the census data is not available, we cannot use random sampling technique or stratified or systematic. We have to think about the alternative, which are non-probability. So if you want to know the success of certain, medicines, some new medicines or drugs have been introduced, and its efficacy. So it's only the experts who have, or only the patients who have on whom the experimentation have been conducted. Only they can share experiences. So we know the target group. So purposefully we have only picked up the one who have the knowledge and the experiences, and they only can share the information which we are interested in.
Okay, okay, ma'am.
Okay. Right.
Yes.
And lastly, the sample size determination. Again, this is the question: and what should be the right size of the sample in qualitative research? So it is the sample size in qualitative research. It has been a subject of enduring discussions. While in the quantitative research, uh, you know, there are certain statistical tools and techniques. On the basis of this, we can determine the sampling techniques, which I will be discussing in today's lecture in the end of the last half an hour. So qualitative research, the experts, they argue that there is no straightforward answer to the question of how many. So if you ask question that how many samples should I picked up for my qualitative research in purposive sampling, or in convenient sampling, or in a snowball sampling. So justifying the sample size sufficiency, in qualitative researches, it's quite debatable. So everybody wants to know what is that magical number for sample size when I'm doing qualitative research. So that is an area of conceptual debate and practical uncertainty. So, what is the right answer? So, according to me, in qualitative research, sample size it's not governed by the statistical power, uh, but rather by the, it's the quality of the your sample, which provides the fresh insights to your research topic. There's a term called the saturation. So we collect information till the saturation point is reached. And the saturation implies that researcher has gathered enough data to comprehend the phenomena under investigation. So unlike quantitative studies where large sample sizes enhance statistical validity, in qualitative research, we should focus on the richness and the depth of information rather than the numerical threshold. We shouldn't be thinking of the size should be 30 or 100. What is the common approach we involve? That is called iterative, data collection. So we keep, collecting information unless and until the redundancy occurs when we are not getting new information. So when we are not getting any additional data, and we stop there and we call the saturation point has achieved. So what is that thumb rule? Thumb rule is n plus 5. So if the saturation point, suppose I am conducting an interview, so if the saturation point is reached with the 25 participants, I'll consider 5 more. 25 plus 5, 30 would be my sample size. All right. So any question on it? Any doubts?
Madam, how is this saturation point being fixed, madam? Is there any criteria for it? Like,
So as I mentioned, the saturation means when we keep, so we, interview can be semi-structured, it can be you have structured questionnaire. So when you are asking questions and getting information from the respondents, you are keeping track. So when the new information, I mean, till the time you're getting some new information on your research study, now the similar, responses you are getting. You're not getting any new information on the topic which you have undertaken.
okay.
That we are calling. So that is, of course, your, it's your researcher's call. That is the threshold has reached. I have studied enough with this 30 or 40 interviews which I have conducted so far. I have, enough information on the, diversified, with the sample. Now, if I investigate more and more, nothing new information is coming. So that's the point we are taking a call and saying now it's a right time to stop. So that's why I started. There is no in a formula which like we have in the quantitative research, we have some formula through which we can uh, find the value of n, that is the sample size. Here we do not have any, unlike in a quantitative research, here we do not have any statistical formula. So actually we don't look forward to the quantity. So number of samples, if your sample size is say 150, that won't ensure that your research is actually very rich in terms of the content. That richness might, because how you have selected your sample, if they are from the diverse background. So if even 25 samples might give you the 20 different perspective to your research questions, and adding more and not giving any new perspective to my particular study. So I definitely, as a researcher, I firmly believe that since my time and my resources are limited in hand, so beyond going beyond this is like it's not required.
Madam, do you mean to say that universe has no impact on the selection of the sample size in the qualitative research?
No, I'm not saying that the universe, the population, see, the
Yeah.
population can heterogeneous. So the sample has to be representative. Sample should have all the characteristics of the population. This is the basic the concept, right?
Yep.
While we choose a sample. Now, how to make the sample representative is entirely based on the researcher's skills and expertise. So when we are using purposive sampling or a convenient sampling or a snowball, any other sampling, right, we try to make our sample as diversified as possible. So when we are even purposefully, when we are choosing a sample, as ma'am said, so there has to be sample has to be from, it should include the different, demographic variables in it. The sample, the respondent, they should vary across the age. They should be from different educational background, different occupational background. So that means my sample needs to be diverse. But increasing sample size only in case of qualitative, this is what I understand, that is what, again, I told you, it's on in the debatable part. So increasing, like the law of in a law of increasing sample size, we call the central limit theorem. So higher the sample size, bigger the precision of the whatever your sample findings will be more accurate towards the estimating your population parameters. So higher precision usually is being achieved when a sample size is large enough. Now question is how large it should be. So that is kind of a debate, is that this is some of the experts, they are saying that it is the researcher who needs to decide it. So where the saturation point has reached. The saturation point may be with the 30, it may be with the 90 sample, it may be beyond. If you till this, iteration of the reiteration process will keep going on until and unless we feel that saturation point has reached. Then no, now the further the information are redundant. That is what I'm trying to mean.
It is, you mean to say that it's the discretion of the researcher?
Exactly. The qualitative research is the discretion of the researchers. We started with the notion, it's the non-probability sampling doesn't depend on chance. It depends on the choice of the
Research.
researchers.
Okay, madam. Yeah.
Okay. And that's why the qualitative research in that way, it's not research itself, it needs a lot of commitment and a lot of hard work. Qualitative research, and nowadays it's very popular, and the mixed methodology, it's not the only quantitative study. So qualitative research needs a lot of skills, that understanding where the saturation point has reached, how should I select my sample, because there is no thumb rule as such. So that needs some expertise and learning, relearning, kind of.
Okay.
So now I'll come to the from non-probability, the probability sampling, how we do it. So probability sampling, as I mentioned earlier, as the name suggests, is a random. So the selection of the sample is totally based on chance. There is no pre-defined notion or no predefined criteria on the basis of which the researcher will pick or recruit the sample. So every element has an equal chance of getting selected to the part of the sample. What does that mean? So for example, if I want to select, say, randomly 20 participants from a group of, 50 participants. So each 50 participants, the best way, or the way we do it, it's the lottery. So I'll make 50 slips. I'll write the detail and some name or some other information on the piece of paper. I'll put it in a bowl. I may conduct a lottery, and I'll pick 20 students, and each student knows this 20 selection of 20 is totally based on chance, on their luck. So 20 names will be, 20 students will be selected, names will be picked up. And no one can say that because of the, researchers' individual biases, there is no favoritism in it. I didn't pick up 20 favorite students from the batch of 50. It's only those lucky 20 whose name have been announced to a lucky draw kind of. So this is what the probability sampling is. So when do we use the probability sampling or the simple random sampling where every element has an equal chance? Now, what do you mean by that? So when I have 50 students, okay, which is part of my entire population, and I am interested to select any 20 of them. So each 50 student has an equal chance of getting selected. The chances of being selection is 1 by 50. Now, whether they will be selected or not, that is totally on chance. So that blame doesn't go on the researcher, or you cannot say the researcher biasness has somehow been part of this. Somebody, I have excluded some part because I was biased towards it. So in an organization, maybe suppose if an organization, there are 500 employees and the HR team wants to conduct some team building exercises. Okay, so the team wants only 50 out of 500, so they can prefer picking up cheats out of mole, and in that case, all 500 the employee name was there in the chits, the names were written, so they had an equal opportunity of being selected. So the first thing is population size. When it's known to us, we have some details about the population. So then only we can conduct this simple random sampling. It is ideal when the population is homogeneous to make my sample representative one. If my population is highly heterogeneous, in that case, I'll advise the researcher not to pick simple random sampling. There are other probability sampling where you can give more preference to them than simple random sampling, because when your population is highly heterogeneous, it has diversified individuals, then selecting randomly on the basis of lottery, your sample may not be representative. And if you ask me, what is the best way of doing? Do we have to, make this sleep? Because this is also a time consuming. If I have a database of 500 employees, how will I do it? The database could be even larger for the multinational organizations when they have different branches across the pan India and the global branches with the lakhs of employees. We have this computer software, we have the functions, we just, it takes not even 5 minutes, I will say it's 2-3 minutes maximum it will take. There's a random number generator, we generate random numbers, and on the basis of that we can pick the any 50 or any 20 out of this. All right, so now simple random sampling, so basically that's the easiest one, picking up on without any criteria. And as such, whenever your study doesn't need any criteria, so because when you're sending your 50 employees for some team building activities, here you do not have any preset criteria, but when you're sending them for a training program or for some other programs, and then you are checking their prior background, so you might think of not taking them or selecting them on the basis of the simple random sampling. There can be some predetermined criteria. You might think about the purposive sampling in that case. So now moving forward, the next option that we have under probability sampling is systematic sampling. Now, what is systematic sampling? As the name suggests, though it is, probability sampling, but we use certain system, there is certain pattern, in it. So what is systematic sampling? In systematic sampling, we select every kth item from the population. Now, what is K? K denotes sampling intervals. So let me take an example to make everybody understand. Suppose if we have 320 names and we wish to draw any 32. So what is my population size here? Can anyone tell me what is my population size?
Please repeat the question, madam.
Ma'am, 320.
Yeah,
320.
in this example, when I'm explaining systematic sampling, what is the definition? The definition says that in systematic sampling, every kth item will be selected. So K is called sampling intervals. Now, to explain the sampling interval, I took an example. Suppose if I wish to draw 32 names out of 320, so 320 is the totality, which we call the population. So, and population we denote by capital N. From this capital N, we want to pick any 32. So my sample size small n is 32. So K formula, just let me check if I can use the pointer here. No, I cannot actually. Okay. Okay, so we take the ratio of the sample with the population. So 32 is my sample and my population size is 320. So capital N by small n, 320 by 32, it's a round off now. If it's even it's a in a decimal, we'll take the round of value. It's 10. Now, what does it mean? This 10 is the sampling interval. That means every 10th name or 10th individual will be selected. So in this process, the first selection will be completely random. So from the number 1 to 9, we can start with any number we wish to. Okay, so from 1 to 9, suppose if I feel the number 6 it's something, it's my number. If I give 6 preference to other number, I may start with 6, I may start with number 5, I may start with 4. Again, this manual calculation is almost obsolete now. So again, I use Excel to use the random number generator that generates the first number, so that again, the no biases should come in between. So the first number will be it will be generated by the software. Suppose the software generated a number 6. That means my starting number will be 6, and every 10th item will be selected. So how this rotation will take place? 6, the next item will be the 16th, then the 26th, then the 36th. This way, the 32 names will be picked up, and we are saying this sample is, the technique that we deployed, we used to pick this sample of size 32 is systematic sampling. Hope I could explain it to my audience.
Yes.
All right. So where do we see such kind of systematic sampling? So in household survey, so for a particular locality, so when you are geographically, if you're exploring an area, so, often the researcher might have a tendency to, visit only the first 10 houses or the 20 houses, because that is easy, because you can say this is a random sampling. I went to any 20 houses or any 30 households and I gathered this information. But the inspection of the entire locality, sometimes it's very important. That is, you need to explore the entire population, because sometimes in the some locality, the houses which are, facing the roadsides or maybe in the entry side, that might be the people are from a higher income group. As we move inside, maybe the income level could be different. So since my population is diversified, it's vast. So if I maintain this fixed interval, that we can actually explore the entire population, and we can say this, in that case, my sample is more representative as compared to the previous technique which I discussed, is the simple random sampling. So for an household, for a market research survey, and then we know for many organizations, they use the systematic sampling for their quality checking. So when they're checking the quality of their products, products manufactured by machines, so at a fixed interval of time, maybe every 50 minutes or every 15 minutes or 10 minutes gap, one item will be picked up, that will be checked, and the experts will write a comment on it, whether it passed all the tests, whether it's yes or no. The quality checking reports are being made like this. So the merit is that it's a kind of an improvement, you can say, over simple random sampling because it's spread more evenly over the population. But it's not truly a random, somebody can question on it. Like, because since we are following a pattern, like every 10th item or every 15th item, there's a constant interval in it. But in that way, it's a kind of, it's not truly in a strict sense, it is not random. But except the first term, rest are, the selection is happening in a predetermined manner by the constant interval. Yeah, right. Uh, the next one is stratified sampling. So stratified sampling, what we do, again, the population under study that is large in size, is heterogeneous in terms of the characteristics, and we have information about the entire population. So given these three things, what the researcher mainly prefers, or what the researcher do, the technique stratified sampling we use, where we divide the population into some small subgroups which we call strata. So a population is divided into small strata. Now, how a strata is being divided, I'll discuss in detail. Now, first of all, so let's see what are the steps we follow in stratified sampling. The first step is the population will be divided into smaller subgroups. Each group we are calling strata. Now, in terms of the characteristics, each strata is homogeneous. And when we move from one strata to another strata, they are highly heterogeneous. So among the strata, we could observe the heterogeneity, but within strata, there is homogeneity. Now, how do we do that? That's a question. And once we create the data successfully, which is very time consuming, and a lot of time and the cost would be involved in it. So when we create data, how the elements are selected from each strata for our own study. Okay. So let's discuss one by one. Now, stratified sampling, it has an application in all the discipline. I mean, in social sciences, in education, in psychology, in the even the health sector. Suppose a researcher wants to study health insurance, because health insurance, the medical policy which we take, it's not same. It depending on our age, depending on our income background, it's the preference would be different. Premiums also would be different. So what a researcher can do on the basis of the annual income, uh, one may divide the population into some subgroups, like the lower middle class, higher income group, and even the reach or the elite section. So one again should be very clear how you are defining your strata. There has to be some common characteristics. So common characteristics again for that it can be any of the demographic variable. The common characteristic can be on the age, it can be educational, it can be occupational background, it can be on the basis of the marital status, and so on, ethnicity or nationality, because all these have some influences, might have some influences on the study topic. So suppose a researcher created a strata, like the first strata includes the individual who are earning below 20,000 per month, the another group earning between 21,000 to 30,000, the third strata earning between 31 to 40, then 41 to 50, and so on. So once the each strata, so we have different income group ready. So by doing this, uh, researcher might target, some strata, or you know, now we have all the respondents of different, characteristics. So marketeer now, for whatever policy they have in their hand, depending on that, now they can decide which income group they would like to target, which so that they can create their roadmap and they can have more fruitful results. So, like if we create four, suppose, or five strata, like in the picture, we have three strata. So, like there are three different characteristics, maybe three different income groups. They are lower income, middle income, and say higher income. So now, once this strata is ready, next question. So next question is, how should items be selected from each strata? And the third question, how many items be selected from each stratum, or how to allocate the sample size across the each stratum. Now the first question answer is very clear. The strata can be selected on the basis of some common characteristics, that is the investigator needs to identify on the basis of which characteristics they want to create the strata. So each strata will be homogeneous from within. Now, but the heterogeneous across the group. Now, to answer the second question, now how to choose items from each strata? Usually we adopt simple random sampling. Now, the reason is very clear. Once we have a homogeneous strata, selecting 10 odd, we don't need to think critically now. So we don't need to use some analytical mindset, because all this, individual in terms of their uh, experiences, in terms of their behaviors, they are similar. So we can select any 10 and any 20 from each stratum to include in our study. Now, to answer the third question, that how many items from each strata should be ideally be selected. Now, to answer this, there are two techniques. One is called proportionate stratified sampling, and the another one is disproportionate stratified sampling. Now, proportionate stratified sampling means the number of sample units in various strata are in the same proportion as found in the population. That means, in my population, better I take an example so that I can connect with my audiences. So see, suppose we want to study the number of employees. Maybe the study is job satisfaction or a motivation level. So we have different types. Total number of employees in an organization is suppose happen to be 750, and on the different the categories we have the hierarchy. So we have top management, we have middle level management, we have lower level management, supervisors, clerk, secretaries. So the total number you can see in the bifurcation. So we have 15 in total from top management, 30 from middle management, and so on. The proportionate sample, a proportionate stratified sampling means the proportion in which they are present in the population, the same proportion we are maintaining in our own sample. Now, what does that mean? Top management, there are 15 in total out of 750. So 15 by 750 into 100. That means the top management comprises of 2%. So in totality, their percentage is only 2%. Middle level management, that is, in the aggregate, the 4% of in the total, the middle level management, it contributes, or it consists of the 4% of the aggregate. So this way we have to find the percentage of the each group in the population. And if we maintain the same in our strata, that will be if we maintain the same in our sample, we call it the stratified sample. Now, what does, again, let me take an example. So if I choose a sample, okay, a sample of say 100, So in 100, 2%. So in my own sample of 100, I'll include only 2% from the top management. That means in number, I will be interviewing or I will be collecting information from any 2 out of 15. Okay. Again, the middle level, it constitutes only the 4% of the totality. So if my sample size by choice, if my sample size happens to be 100, so 4% means the 4. So 4 level, middle level management, will be part of my sample. So the calculation you can see. So if this way, if this exercise we are using, we are calculating the percentages in which they are present in the population, actual population, and exactly the same percentage we are trying to maintain in our own sample. We are calling it, we have used a proportionate sampling. The purpose again is very clear because we want the sample to be very representative. So the way they are present, if our sample we maintain the same percentage, our sample will be a kind of a right representation of the actual scenario. But there can be divergence from this. One may choose or go for disproportionate sampling as well. Again,
Excuse
it's
me,
a yes.
I have one question. How do we determine that we have to take like 100 out of the 750?
No, that ma'am, there is no rule. The 100 is just for an example I have taken.
Okay. No, I mean like
Sample size is suppose sample size minimum it should be the 1% of the population. This is something thumb rule. So the population, there is a theorem called the central limit theorem. I'm already mentioned. The bigger the sample size, closer will be close to the actual population. So the sample size, again, the size, how many samples you want to keep in totality. So here we are taking, now we have some calculation, I'll show you. If your question is that why I'm mentioning it's 100.
yes.
So there are
Because
certain calculation based on the confidence interval, what is a confidence interval, what is the level of error, the standard deviation. If we have some information, prior information, we can decide on what should be the right size of the sample. Here, just to elaborate and explain it to my audience, I have taken, this can be 200 or 250. What I'm trying to explain here, once you decide your sample, that my sample will be of size 250, the question is how this 250 you are allocating among the different strata. Because this 250 will come from the different strata. And total number of strata can be 4 or 5. So it depends on, again, how your criteria, on what basis you have created these strata. So like and for example, if on the basis of the income, if you want to create, so maybe it's a lower income, lower middle income, the middle income, upper income, the elites. So if you have 5 groups in totality, so 5 strata we have, from each strata we are selecting certain members and we are including in that 250 which we decided. So stratified sampling in proportionate means in the percentage they are present in the actual population, the same percentage we are maintaining in our sample. And I'll answer your question, how do we decide that it should be 100 or 150, which we call the sample adequacy. The concept, is it clear? Proportionate means first we need to understand in what proportion they are present in the population, and maintaining the same proportion in my own sample is nothing but it's a proportionate stratified. But it again depends on your study objective. Maybe this is something some motivation level or some leadership quality, whatever your research topic, which demands the study should be more the top middle level and the lower level management oriented. So instead of, you can see in the another scenario, the researcher, instead of choosing the proportionate stratified sampling, he chose disproportionate sampling in his sample. He has increased the number of middle level management and the lower level management and reduced the clerk, because this is something their opinion. and in comparison to their experience or opinion or their behavioral study, it's more towards the lower level and middle level management oriented. So this way, it's again the researcher decides whether the one should go with the proportionate stratified or disproportionate. Is it okay?
Yes.
Yes, ma'am.
Okay. I'll come to the sample size, ma'am. We have 25 minutes, so I quickly now go through this cluster. I'm sure all of you know that cluster. What we do, it's the same. It looks similar, but it is different. We divide population into various subgroups. Now this time the subgroups are heterogeneous in nature, and when we see one cluster to another, they are more or less homogeneous. So it is one of the probability sampling technique where we divide the groups, into we divide the population into various groups. We call them clusters, and from each, there are different levels. There can be even multi-stage clusters. First of all, if we divide the population, suppose into 4 or 5 clusters, we can choose only one cluster and study entirely. If that cluster is large, too large, we can divide it further. That's the second stage. Like, maybe if you want to study across the pan India, or maybe my study is based on a few states. So maybe going pan India is quite impossible. So I'll identify maybe only the West Bengal. My study is confined to the West Bengal. Even the West Bengal has so many districts. So further we can narrow down. So that is the second stage clustering. In a particular, the district is also large enough. So I'll further go down. Like if I choose only the capital Kolkata, and if I say only my study is based only South Kolkata, only North Kolkata. So that is the stage clustering. So in this clustering, what the researcher wants, actually researcher wants to create some clusters. Let me take an example of this. Suppose a researcher wants to conduct a study to judge the performance of the hybrid mode in business education across India. So now we have, after pandemic, we have can see there are many courses, even this is an online mode, but there are hybrid, we have offline and online together. Some participants can join online, some participants can be physically present. So how effective it is, if the study is oriented, towards this. So suppose the researcher has identified few universities, and they all are approved by, say, UGC. And it is impossible to conduct a research that involves student in every university. So we have all these university A, B, C. These are my clusters. So they are heterogeneous. Okay. So what the researcher can do, instead of studying all the universities, we can pick one and study the entire cluster. Okay, this is the one stage clustering. So this cluster then is defining the student population, in India, they're studying through hybrid mode. And now from this cluster, so we have again large number of observations in it. So we can take few of them. Okay. So instead of simple random sampling, because I told you simple random sampling, if it's highly heterogeneous, we can think of an alternative. We can go with systematic random sampling. So we can apply systematic random sampling. We can narrow it down. We can take out some part of it, from the clusters which we have identified in the first stage. And this is the way we can continue our study. And this is we conduct our research study. All right.
Madam,
Yes.
will you please help me in understanding
Mhm.
what is the difference between a cluster sampling and also the quota sampling under non-probability sampling?
All right. So there is quite a similarity. I didn't mention quota sampling. What happens in the quota, we create, see, cluster sampling are heterogeneous, right? For example, if my study is to the services being or the customer experiences of different banking services, and I have chosen few private sector banks, A, B, and C. So these are my clusters. So if I look at the bank A, they have different types of the customers with the different experiences, different backgrounds. These are clusters. Quota are quite similar to stratified. So you take a lot of time to create the strata, and from strata you use simple random sampling. Quota means like kind of we fix the number. So we decide that from each strata, the numbers or number of respondents whom we will be studying. That is, again, we do it. It's not random. When we are fixing up the 10 or the 20 from each strata, why we are calling it a non-probability sampling? Because we are using that our own judging criteria. So purposefully, there are some criteria we have. On the basis of that, from each strata, we are selecting some number, 10 from the first, maybe 15 from the second. So that is we call the quota sampling. So if I'm doing an study on the behalf of the organization I work for, so they might send some instruction that when you are conducting the study, there has to be this number of respondents you should have to cover. So the 5 marketing students in your survey, you need to give 5 marketing students, 10 finance students from the different, on the basis of the specialization I created strata, and from each strata, fixed number as being told to me, I'm keeping that number. So this is kind of, and of course there are some, clarification. It's not that these numbers are not just a random number, maybe because they have kept more number of finance students, because there's something, it's the finance is the most predominant maybe specialization, or maybe the on the placement perspective, this is the finance is the area where largely the placement packages are on a higher side, kind of.
Madam, in that case, in that scenario, if enough number of respondents are not available from a particular strata, or if can we add additional number to the existing number of the strata where large number of respondents are available?
Sir, your population, that is the totality.
Yes.
You are dividing into smaller strata, and you are saying that you are not able to all the respondent in the strata, they are not accessible to you.
Not accessible, madam. In fact, if I talk about what you have just now told, all students from different specializations in the same proportion. For example, we have more number of students opting for finance rather than marketing or some other specialization.
Mhm.
So, for example, you said 5 students from each specialization.
Hmm.
Suppose I have only 3 students from other specialization. Can I make 7 students into finance? Because I will be taking all the 3 students from the marketing. Because I need
What
5
is your
students.
total? What is your total sample size which you desire for?
Yeah, madam, from each, say, suppose 30, madam. 30 is the sample size. Uh, so if you say that,
In totality, your sample size which you are targeting would be 30.
yes,
And for 30, you are selecting your respondents from each of the group or the
yes,
strata.
yes, madam.
So like, and are you asking me quota sampling or a stratified sampling?
I'm asking you about a quota sampling.
So in quota sampling, when we have the strata already are being made,
Yes,
now when I'm carrying out my own research, we are fixing up the number,
yes,
and there is a rationale behind it. So that is the quota sampling. It's a little, kind of an overlapping with the stratified.
yes,
In the stratified, so there's a very thin line of difference. In the stratified, when we are choosing, there is no, I mean, even the 30, when you are saying the stratified, the total is 30. So even you have the freedom, your total can be even 30. You can even increase your sample size to 50 or even more. And it's entirely your decision how you want to take, how you want to include, take the sample from each of the strata. But in case of quota, there are certain, numbers have been pre-decided.
Yes.
So that is only the difference.
Yeah, in that context, madam, is there any probability that some of the sample is overrepresented or underrepresented in the sample size?
Yes, can be. So it depends on, I mean, if I gender wise, if I have created, the groups, the male, female, and on the, so what is your study objective? If it's something which is women centric, you want to take more of the or other genders, so that the percentage can be accordingly, it might be different.
Okay, madam. Thank you.
Okay, thank you so much, sir. And this is the basic difference. We can go through it. And in case if you have any question, otherwise I'll switch to the, because we have only 20 minutes time. All right. Now, how do we decide the sample size in quantitative research? There are certain, formulas, like unlike qualitative research, as I mentioned earlier, which is entirely based on the saturation point. So some concepts we should understand before going to the formula. The first concept is sampling error. So from the basis of sample, we draw inferences about the population. So all the inferences about the population based on the sample may not be correct. There can be wrong inferences or different inferences often we make, because if my sample is not a right representative of the population. So moment there is a difference in the results, I have shared in my PPTs the mu minus x bar. Now what is x bar? Anyone from the audience, what is x bar?
Mean or average?
Sample average, sample estimate. So the entire process I'm just repeating. So we have a population. We are not interested to study the entire population. We just study a subset of it, which is a sample. So when my sample is ready and I have studied it, so my sample estimate, that can be sample mean, is x bar. So on the basis of that sample mean x bar, I'm drawing some inferences, some generalized conclusion about the population parameter, which is mu, and the difference between what my sample is giving and what, if actual census have been conducted, what results I could have obtained. This difference, we are calling it sampling error. And this is very important to measure this error, because my study outcomes, the reliability, the inferences, what I'm making on the basis of sample, it depends on sampling error. So we want the sampling error should be as minimum as possible, and that is only possible when we use right sampling techniques. Okay, now the second concept, if anybody knows this concept, can share. What is level of confidence? In estimation, we have a concept called level of confidence and level of confidence is the same. It means level of acceptance. There is a level of significance, which is the level of rejection. The level of significance we denote by, that is a type one, alpha.
Yeah.
Yes. Anybody was saying something?
Generally, in chi-square test, we go for this level of significance at 0.05 level to see that enough number of respondents have been taken. Is it that, madam?
Okay, it's not only in the chi-square. Chi-square is one of the non-parametric tests, whether it's a parametric, non-parametric, and hypothesis testing. There's a term called level of confidence. Level of
And
confidence
level of
means,
confidence, Uh,
Yes, ma'am.
can I tell something, ma'am?
Yes, yes, please go ahead.
Ma'am, level of confidence means if several times we are performing any test, then how many time it will come similar result. That is called level of confidence. If we are
That is
performing a test for 100 times, then if there is a chance of a similar result for 95 times, then 95%
Um,
confidence.
Rather, I would say differently. It's not the
reliability.
it's actually reliability, ma'am. What you were saying
Reliability.
is
Yeah.
like level of confidence means my sample, my sample outcome is actually being used for drawing conclusion, some generalized statement about the population. So population is unknown, it is unseen, unexplored. My own sample, which I have selected by myself, I have studied it thoroughly, so I have my sample outcome. So, when I'm using my sampling results to estimate the unknown population parameter we just mentioned in the previous slide, of course, there will be some errors in it. Uh, Again, that is, we cannot totally eliminate the sampling error. So, how confident we are when we are making this inferences, drawing some conclusion about the population parameter, how confident we are. So, when a researcher attaches a confidence level of 95%, it means if we take, uh, yes. Okay, if we take 100 instances, 100 samples, if we reach out to 100 different sample respondent in 95 cases. So when I'm saying my confidence level is 95% and level of significance is 5%, that Sir mentioned in his chi-square test, he took alpha as 0.05, which is the level of significance, the error chances. So there's a 95% chances that my sample would be able to, correctly will be able to estimate my population parameter. But there could be some situation where my sample result is quite different from the actual population. And that error chances is 5% when we choose the level of confidence as 95%. Am I clear? So higher the level of confidence means higher the level of accuracy in your own research findings. Could I make it clear now, or should I explain it again?
No, ma'am, clear.
Right? So it's not, we are not checking the validity. So for example, if we are, my sample value is, say, for example, 30. And we are saying on the basis of 30, the population parameter will be somewhere nearly 30. And my confidence level is 95%. So randomly, okay? So no criteria. If randomly, if you pick up any, say, 100 samples from the entire population, okay, 95% confidence means out of those 100 samples, in 95% cases, like 95 samples, what you'll observe, your population parameter were somewhere close to 30. So this sample has correctly, estimated the population for 95 cases. In 5% cases, they are, that is we call significantly, statistically significantly different from what the, intervals we have created. So there is a concept now, in continuation, which is called confidence interval. So confidence interval, that is the formula you can note down, that is the confidence interval we create for the population, which is mu, and the point estimate, which is the sample sample mean, the x bar, and there is a plus minus margin of error. Now this margin of error is, the error which is the allowable error. And again, it's the researcher, you need to decide what is, what margin you want to, set for your own estimation. So this is the margin of error we add and subtract so that we can create an interval. Interval means there will be a lower value, there will be an upper value. and that interval we create for the population parameter. Now, for margin of error, the formula is Z into standard error of particular statistic. Now, Z, I'm sure my audiences are aware of. Z is a statistic, which is one of the used in the parametric test. All right. And I'm just showing you the value so that because, the Z statistic value, it depends on the confidence level. So there is a Z table, statistical table. That is, traditional way we used to calculate in my times when I was in college days. There was a Z table. I used to check the Z values. Nowadays we have the softwares. So it's very simple and easy. So for the 90, 95, 98, 99. So usually we take in practice and research 95% of the 99 because that shows the higher level of confidence or accuracy in the research finding. So just remember for the 95%, the confidence, at the 95% confidence level, the confidence coefficient Z value is 1.9. That's why I'm saying so because I have a question in the next slide. And I would request each one of you just because I need a board to explain, just allow me to stop sharing for a minute, please. It's almost there. I hope my screen is visible.
Yes.
Yes.
Okay. Okay. So here is the question. Suppose we are interested to estimate the average monthly household expenditure on food items by the households of a town. So based on the past data, it is estimated that the TH, I have somehow missed it. It's not he, it's the. The standard deviation of the population on the monthly expenditure on food item is 30 rupees. With allowable error set as 6 rupees, estimate the sample size required at 95% confidence. So first of all, as a researcher, now when you had a question, how do you decide the sample size in quantitative research? Certain things we have to decide in prior to that. Number one, what confidence interval you want to achieve. As I mentioned, as a thumb rule, we use 95% and the 95% because that shows your high accuracy level and confidence on your own research findings. Second one, there has to be some past data available on the basis of which you have information on the population standard deviation. If not, then the sample standard deviation will be a kind of a substitute for that. And the allowable error. Allowable error is the difference between mu and x bar, that sampling error. Understood? So how much margin, or the you want to set. Again, as that's a researcher entirely own discretion, from the literature review, from the understanding of our own subject, we have to decide on what should be the allowable error, how much percentage or how much amount we are allowing it. So in this particular question or a context, just a hypothetical situation where this formula how I have reached into. So if you can kindly note it. So this is the mu, which is the population parameter, and we are estimating population on the basis of my sample. This is my sample mean. My population will be somewhere around the sample. It will be little more or little less, which is the lower and the upper interval. And that we get when we add or subtract this margin of error. Now, what is this margin of error is? So marginal error formula is it is Z into the standard error, and the standard error of the estimate is sigma by root n. Is it okay? This is the allowable error or the
And
margin of error.
we are not able, ma'am.
Yes.
Ma'am, we are not able to see the formula.
What I'm writing on the board, are you not able to see it?
Yes, ma'am, we are not able to see.
Okay. But my screen is visible, right? Sample size determination for large population.
Yes, ma'am. Yes, ma'am.
Now, can you see the screen?
Yes, ma'am. We can
Yes,
Yes.
yes, ma'am.
Okay.
okay.
Okay, thank you for letting me know. So this is the mu, which is my population parameter. Okay, so we are creating the population. We are, and in these statistical inferences, we draw inferences about the population based on our sample. This is the sample mean, and plus minus of margin of error, and the margin of error is Z into the standard error sigma by root n. Is it okay? Now, because the moment I'm using this pointer, I think the visibility, somehow my audiences are not able to visible, because I have to make it a full screen. Just let me check once again. And this is my, no, this is not the placement. Okay. Just let me know and help me know if, are you able to see what I'm writing now? Mu minus x bar. No? Can you see now what I'm writing on the board? What I'm writing on my own presentation?
No, ma'am. No, ma'am. No, ma'am.
Okay.
No, ma'am.
No issues. I'm writing it and I'm showing you. Can I get some responses, please?
It's not visible, madam.
But I have shared my screen. It's showing that you are presenting. So just a minute, because I can understand there's some problem from my side. Just one more time. Otherwise, I'll explain it, and it's also running out of time. And we are running short of time. This is the screen now. Can you see my screen with the calculations with the red pen? Participants, can you see my?
No, ma'am.
No, ma'am.
Okay. Sorry, then that's I'm extremely sorry. In that case, I have to explain. Now, this formula is visible, right?
Formula is visible.
Okay, so how did actually I was trying to explain how did I reach to that conclusion. So no worries, I'll share my PPT with you with all the calculation. So when we are estimating, there are certain steps we follow, and it's quite easy to reach up to this formula. This is actually the ma'am which you wanted to know initially, how to decide the sample size, how big my sample size would be. Will it be 100? Will it be 150? Theoretically, because once we decide the sample size to be 500, we try to contact, we send questionnaire maybe, and then we could reach up to maybe 480, and then finally my sample size could be reduced to 480. This is the formula we use. So Z is the Z statistic. By Z, I'm referring to Z statistic. Value depends on the confidence interval we choose. When my confidence interval is 95%, the value is 1.96. Now, sigma is the population standard deviation. In the question which I had shown earlier, the population standard deviation is known to me, so I'll put 30 in place of the sigma. What is E? E is the allowable error. How much difference you are allowing between the mu and the X bar, which is again 6 rupees. So if I put all these values in this and I solve for this, so this is 30, this is 6, they'll cancel out. Okay. And finally, when once we finish the calculation, we'll get the value and the answer that this is the sample size. This is called sample adequacy. So if the answer is, say, for example, it's 50, so it is advisable not to take any sample lesser than, this is the minimum requirement, sample adequacy. So you can take the sample even bigger than this, because the law, it states that bigger the sample, higher the precision rate in our estimation. So sample can be as big as possible, but this is the sample size determination, which is a kind of a thumb rule, which states that this is the minimum sample size it should be, so that it becomes representative of the whole. Is it okay? And the last one for the qualitative study, when we do not have this mean and the standard deviation concept, for example, when we are studying some human behavior, some experiences. So if I ask somebody, are you satisfied with the kind of job you are doing? And only two options I have given, yes or no. And this is kind of, I'm expecting that the, from my sample, that the some preconceived notion I have from the literature review, that 30% of the employees are, they are satisfied with the kind of job they are doing it. So 30% is my p, small p, which we call the sample proportion. And on the basis of the sample proportion, now I'm estimating the population proportion, which is the capital P. The level of confidence, again, the researcher, this is again the thumb rule. We choose 95% confidence level, it automatically implies the level of error chances we have kept bare minimum 5% only. And the result I want within 0.04. So there is some formula I'm not able to show, and because of the time also constraint, the formula, we just derive it. It's there a calculation. And then finally, this is the formula for determining the sample size for the population proportion. N is equal to Z square, P into Q. Now, you can note down what is P. P is the proportion of sample success, and Q is the proportion of the sample failure. Now, what is sample success? In this study, I'm expecting that out of the total population, 30% are happy or satisfied. They'll give answer in favor to my question. Are you satisfied? 30% are saying yes. So my P, the probability of success will be 30. So I'll put here 0.30 as P, and Q happens to be 70% because P plus Q in totality, it is 1. E, in the question, or this is the researcher, it has to decide based on their knowledge of their area. And this is how we decide the population, sample size when we are estimating population proportion. So we are, when we are conducting this kind of a survey, job satisfaction. So before, going for the design, the sample study. So beforehand, I'm ready with my calculation, and my calculation is saying that my sample size should be minimum of 505. So I should not be taking any sample which is below 505. Okay. Are we connected?